Hello everyone, welcome to this webinar on an end-to-end solution by XMPro. My name is John Van Heerden. I'm part of the strategic solutions team as an engineer. So today we'll be talking around the XMPro AI part of our 4 pillars of XMPro. That's this guy right here. And it is a distributed intelligence that is achieved through AI engineering, where people and technology meet to innovate, execute, and augment with AI. So I'll just note as well, we are currently in our XMPro notebook here. So it is part of our suite of applications. That's this guy here. And we'll step into our end-to-end solution example. So going through this end-to-end solution, we will define go through the problem definition, look at some of the related data, the characteristics of that data, visualize the data, identify what is the more suitable machine learning models that we might use, develop these models all within the notebook, and then we'll step into the deployment of sending these models to our data streams, running live data through them, getting some results, pushing that up to our applications through recommendations, and we'll also touch on how to manage your models. So looking at the problem definition for this example, we have a subject matter expert that has multiple pumps in remote areas. This subject matter expert wants to analyze some sensor data, and we actually have a lot of sensor data, I think plus 50 plus sensors. And the goal for this subject matter expert is to be able to identify which pumps are likely to fail and estimate their remaining useful life. The key for this subject matter expert is to be able to prioritize and create a maintenance schedule, ultimately reducing the optimal downtime as the key focus. So breaking this up into the components, we can see that we have a need for a classification model for being able to identify pumps that are likely to fail, and a regression model for the estimating a remaining use of life. And we'll be stepping through that part first through our stepping through data analysis first to get to those two models. So the crux of this problem is that we need the right people at the right place at the right time. The data analysis part utilizes our data streams to bring in our data and our XMPro notebook to do the analysis. So this is a Jupyter notebook style notebook. So it's very familiar to data scientists and engineers who commonly use this platform. So stepping into the data analysis, we'll be loading in our data. So this data is coming from our data streams. So if I click into this guy here, where we have a listener. So we have a whole bunch of listeners in our toolbox. This is XMPro's set. You can also build your own through our extensible library. So you can bring in any types of live data like MQTT, OPC, UA, etc. We can then filter some invalid data points out. So if your sensors go offline, we might not want to bring that into our model. And we can choose to write this to a set of action agents is what we call them, a set of data storages. So we also have a wide array of choices here. In this example, we'll be choosing just to write it to CSV and pull it into our notebook. With the data now in our notebook, we can go through extensive or basic, in this example, basic analysis, looking at some of the characteristics, looking at the top 10 rows of data, summarizing our data. And something to note about this data as well is from our maintenance system, we've now labeled this data with our machine status. So we can see that there's 3 states: normal, broken, and issue. So ideally, we want to identify these issue states for our classification model. The next step is to visualize our data, get a good idea of how our data relates to each other. Since we have a lot of sensors, we're going to push our data to a principal component analysis space. That brings it down to 2 dimensions. That's a different transformation of the data for us to visualize and identify clusters for our classification. So here is the code for visualizing the data. So this is just a contour plot with the principal component space. And here's our results. So we've got nice interactive plots here. I've got a contour plot on the right side and a density contour on the left side. And if we actually just pull away all our null points, we can see there's a nice clustering of our issue states and where we find our machine breaks down. So we can see that there's significant groupings for the issue states closely related to the broken states. And this is a nice indication for us that this could be suitable for our classification. Of course, we can go a lot deeper into this and look at a deeper analysis and transformations on this data, but this is just a simple example. Please also take note that this type of data that works really well is not always viable. It depends on the data characteristics and how we transform the data, how we clean the data, how we do feature engineering, etc. So now that we've had a nice look at our data, we've got a good idea of what we're working with. Let's jump into our development of our 2 models. So this will be achieved through our data streams. So this is where we keep bringing in the data and our notebook that we're in currently. So the first step, classification of the at-risk pumps. Choosing a model, that's up to you. So I'm choosing a random forest classifier. Typically, someone might start off with something that's very basic, or use an AutoML library to optimize your model selection and hyperparameter tuning. It gives you a good starting block. So this one will just be a vanilla random forest classifier, nothing too special in the hyperparameters, just something that gets us nice, basic, clean results. So this is the code that does the classification. We do a test train split for our data that we've now pulled out of. We're using data streams into that CSV, and we run this classification model, and we look at some of the evaluation metrics. And we can see it's actually got a very, very nice score. Broken, it doesn't have, there's not many cases. We've got heavy class imbalance there, and we're not too worried. We would like to know that there's a good distinction between our issue cases and normal. So this gives us great results for that, indicating that this model will do a good job at classifying our at-risk pumps. So once we've created these models, we can now save the model files and use them into our data streams, which I'll show ahead on the deployment stage. So this is our classification model. We can now jump into our regression model. So we've now taken our data and creating these 2 models to bring into our XMPro application. For the regression model, what I've done here is I've just, in this first block, created a calculation to identify the number of hours until the next broken time. And in the second part, similar to the first, I've chosen just a gradient boosting regressor, just a model, very basic. I have a test and train split, and I've run this and it got some evaluation metrics at the end here. Again, very nice scores for this data set. So we can see that our squared score is above 0.9, which is a very good indication. So we can see this will give us a nice prediction for the remaining use of life. Once again, we save these model files, and I'll just recap on that one. So for the deployment stage, we now have our models, and we will want our subject matter expert to be able to interact with these models. So I'll click through here. Sorry, we're this slide. So this is what we have at the moment. So we have our 2 models, and we've brought that in from our data. Now we want to be able to apply live data to these models and surface this to a interface that our subject matter expert can open up on his laptop, wherever he's at, he or she. So looking at the problem definition, we've got our models, but we would now like to create the maintenance schedule and start getting value out of these models. Your deployment options are wide, and there are many options available through XMPro. There might be various reasons why you might need edge for computational speed or security, cloud, or a hybrid. And we've got a range of methods to apply these models. And so as our entire set of data streams can be configured through these options. So taking our models, we will now put them into our data stream, and we're actually going to model chain these models to save on some computational power if needed. Apply live data to them, and this live data will then, the results from this live data will now go into our recommendation engine and also surface into our application, giving us insights and for event intelligence. So I'll just open up our data streams and recommendations and applications just to show how the three gel into each other. So in our data stream, this is where we are now applying our two models. So we're using the Python agent here, and we've got our model scripts in there. We can point this to any Python instance we like. So if we want to go execute this on the GPU, we can set that up. And this is the other model there. So how this data stream works is we bring in our live data, we prepare our JSON package. It goes into our first at-risk pump classifier. This will give us a true or a normal or issue classification. So I'm just looking at the live viewer here. This is just primarily used for visualizing what's going on here. It's not our main point of analysis, just to get the flows working. So this data is coming through. We'll be waiting for a data set to come through now. So we can see we've got some data come in. We've got a range of sensor values, and it's gone into our model, and we've got a normal result. So at this point here, the normal result gets filtered out, and that's the end of that set of data. The model, the data points that are identified as a fault or issue, they go into our prediction remaining use of life model. This will now on that pump give us our remaining use of life. We extract our asset name, and then we broadcast this to our recommendations and our application. Our recommendations, so that we can write some rules for some event intelligence alerts, and our applications, so that we can visualize the type of data that's coming through. Here's our recommendations. So this is a recommendation rule I've set up called pump at risk. I've added one rule here for the remaining use of life. And in my alert headline, I can push live data into this alert headline. So from a glance, you can see how many hours it has left. I've created a set of alert descriptions. So this rule is around if I have a pump that has a remaining use of life less than 100 hours. So these are the ones that maybe I have a couple of pumps that have a certain level of urgency, but these ones are imminent failure, critical risk. So I've set this as a high ranking, and the rule set for this recommendation is when this remaining use of life is less than 100. I can now add additional triage instructions and information around this recommendation, and I'll show how this configuration surfaces in the application as well. So clicking into our application, what we have here is we've got an interactive map on the left-hand side here. a list of our assets in a table, and these recommendation rules that have come up from our recommendation we've set up. So also note here that we can set up notifications for this recommendation as well for more specific urgent action. So we can set this up as just the basic name, and we can send this out as an email or SMS. Coming back to application, so here we have our list of pumps. So this data is getting fed live from our data stream, and we can see here we've got a remote location, very remote, potentially requires a helicopter for this type of servicing, and we can identify just visually our issue pumps and how the remaining use of life on them. So I can now zoom in here and just this by visual inspection can start doing my scheduling and mapping out there. So looking at the recommendations that I get for these at-risk pumps, I can now click into a recommendation. So this is the recommendation we set up in the previous configuration, and I can look at some of the event data coming through. So I can see, okay, I've got 94 hours left on this guy. This is a critical one. I can start writing notes on this pump and submitting work requests. My maintenance crew can now go to this pump, follow some triage instructions, looking at how to diagnose this pump and what is the best course of action. We can build a discussion around this pump, look at a timeline of what has been done to this recommendation, look through some analytics for this specific recommendation. So if we see this pump continually has a low remaining use of life, there may be a persistent issue there. After we've resolved our issue, or we've done our analysis on the diagnosis on the pump, and we've amended an issue or identified the issue, we can come down to the bottom here, and we can either mark this pump as resolved or mark it as a false positive, and this can then come back into our data set for retraining and refining our models. So that's a very nice feature there. So from the point of view from our subject matter expert, we want to open up our laptop in the morning after our coffee or tea, and we come to this map here, and now we can have a look at our pumps, set up our scheduling, and this might be manual for this first instance, and I'll show just in a second how we can bring optimization into this, and we can keep iterating on this application as our models become more refined and advanced. So just going into the edit mode for this application, we see we've got a range similar to our data streams. We also have a toolbox for our visualization elements. So I can bring in something like a calendar, rearrange and adjust my layout, as well as additionally creating template pages and additional pages that I can drill down into, so I can dive into specific assets. I'll just cancel that one. Fantastic. So this is what I've shown here. So we've got our two models from before. We've brought them into our data stream here, and we're pushing that data through. We've got our chained models so that only the at-risk pumps go through for prediction of remaining use of life, and we surface this all the way to our application. So I'll just start up again. Our application here, where we also have alerts set up for remaining use of life less than 100 hours for our more critical events. So on top of this now, I can bring in a scheduling model. Similar to my machine learning models, I can go and bring in any type of library I require to set up the scheduling optimization problem. I can go through with real data. I can store some real data. look at some of maybe I've gone and created a few manual scheduling sheets. I bring all that in, I can analyze it, I can bring it into this and compare it with this algorithm, see if I get any performance boost. And so this is the process of going through developing this OR tools model. Use just a constraint solver. And at the end, I get some results out for, okay, if I need to travel to my 6 most critical pumps, this would be my optimal route, and it gives me a distance metric for this. So in a similar fashion as what I've brought in my machine learning models, I can now bring in that model through a Python agent as an example. There's as aforementioned, there's a few different options you can choose. I might bring that in here, and then from my list of pumps, I can tie that in, and then from there on out, I can take that schedule and present it, boil it up here. So I've got an automated schedule that reacts to live data. So every time I get a new live data point in, and I might set it up to wait for every hour before running my scheduling model, but I've got an hourly updated live scheduling that I can access by just opening my laptop. So the last point here on the end-to-end use case is the management. So now that I've gone through and I've developed my machine learning models, and the beauty of using these notebooks and getting your data in with the data streams is that I can iterate quickly on these models. I can get results quickly. I've got graphical interface fast. I don't have to do mappings to extensive mappings to get a point solution visible on a page and usable. I can iterate quickly on these models, and then I step into my refinement process. And this refinement process can lead to very complex models. So that may be my optimization model or my 2 machine learning models. And this is where management comes in to look at some of my slides are kicking up. There you go. Go back on. To look at some management options like model registries. So benefits getting in some metadata of the models, the lineage, versions. I can put models into production. I can iterate on these models, add annotations, and all this type of extra information about the model. That's not just a set of a file with weighted values in there. So if I go back to my data stream, so an option of this is MLflow. We've got a wide range, and there's a set of options that you can choose. So the example there would be that I have my model repository sitting here in place of where I execute my model. Here I can select my model. So I might have version 10 running, and I push my live data through, and I get it all surfaced up to here. And I've got a team working hard in the basement, and they're working on the greatest, best model with some brand new data, and they've upgraded this to version 3. I can click into this, set it to version 3, and it automatically comes into this through this data stream. So this is the end-to-end solution for this specific example, where we've defined our problem. We've identified what kind of models are required, what kind of actions would the subject matter expert, how they would interact with this application. We've looked at our data. This has come from our data streams. So we've got live data, we've stored it in some storage, and we've then looked at the characteristics of this data. We've transformed it into a different space, the PCA space, and visualized it in a 2D way so we can identify those clusters. We've then stepped into our development. So that's looking at developing our 2 machine learning models, looking at their results, the metrics that come from them, and getting an idea of whether they're suitable for the task. And it will be dependent on your task. If you have something that's more at risk, something with that it may have a lot of false positives, may not be may be good. So we do all these kind of decisions here at this stage then, and then we step into our deployment of how do we get this into the streams? Where do we want this to run? What kind of security do we need? Do we need this at the edge? Is it highly computational? Those types of questions. Then we look at taking our resulting models, getting into a management system, and continually iterating back on. So once we've got to the end of one stage, we've got some good results, we might have a bit of feedback from our subject matter expert that will tell us this is not quite how this works, this model gives us too many false positives, etc. We go through, we redefine our problem, well, we enhance our problem, we bring in some new data, might need to bring in some more different variables that will account for some variance in our resulting data. Go through the development, we might use AutoML, we might tune our hyperparameters, the data might change. So there's a set of different there's a lot of variance through this process, and that's why it makes it such a benefit to have a fast iterative process through these XMPro notebooks. And we step through all the way again back to deploying these models, getting them through, building up our application, creating maybe potentially some drill downs where we get to the pump level, and we might look at the pump data, visualizing that directly at the pump from this interface. And we can even step this further back into looking at maybe I have, for each state, I've got a set of pumps, and I want to look at the set of pumps for those states, and I can allocate a person to look at a unique page that's focused purely on Northern Territory, for example.
Okay, thanks very much, Sean. We've just got a few questions that have popped in during the session. So the first one is, why and when would you use the Python agent rather than Jupyter Notebook?
Yes, so the Python agent would be if you have a pre-existing solution, or you have a very simple type of script that needs to run, or maybe a library that just takes in data. Your notebooks is a lot around investigating, visualizing, all on a common platform that everyone on your team has the same set of libraries. You can share the notebooks. So this is a collaborative type process here. So that would be the reason why. So the results from this notebook investigation, it ends up being a Python script that you bring into this agent here.
Awesome. And just one other one, I've got time for one more question. Does it support decoupling of development platform versus deployment platform to be different providers? For example, if deployment is on AWS/Azure while development is on XMPro platform.
Yes. So it would it depends on what the setup is, but that's sorry, can I get the last part of that question again, Sarah?
Yeah, so does it support decoupling of development platform versus deployment platform? So can it be on different providers? For example, deployment is on AWS and development is on XMPro.
Yes, that's right. Yes. So you can go and deploy, develop your models anywhere, and through our extensible library, you can also build agents to even interact with those deployment points, depending on if they can actually serve models, for example. But that's 100% viable to go and create and develop somewhere else and bring it into our data streams separately.
Excellent. Okay, well, that's all the time we have for questions today. Thanks very much, Sean, and thanks everyone for joining us today. If you're looking for more information, you can contact Sean or our team directly, and we'll send out the recording of this session shortly. Join us next month as we share how to accelerate your digital twin use cases with our blueprint accelerators and patterns repository. and you can register via these links in the chat box here. And we look forward to seeing you all next month. Thanks very much, everyone.
Thank you, everyone.